So few things we have discussed the last time under the clustering part, and mainly we talk about the two types of algorithm, the simple k-means clustering as well as hierarchical clustering. So those are the two commonly used clustering algorithms. Uh, when we talk about the details of k-means clustering, the idea of k-means is we started with searching for a k cluster centers among the data points. And k will be a parameter, which means before you start, you have to have an idea about like how many clusters you search for. Otherwise, you have to experimentally find out the number of k. For that, you can use root mean square, which means how similar your clusters are. Right. So the basic k-means clustering algorithm we have already discussed. The idea is you initially start with the k cluster centroids, and then you assign each and every instance in the data set into these initial cluster centers. And once it is assigned, you recalculate the cluster centers and you iterate this so that these cluster centers will not move. And remember one thing we discussed, that this will be totally depend on your choice of, the starting two cluster center points. Sometimes you might get, different outcomes based on the different, starting cluster centers. So in that particular case, you have to repeat multiple times and find the appropriate, outcome. And that's what we need to know about the k-means. And as finally, like I said earlier, the quality measurement of the cluster is very important because we really don't know sometimes how many clusters we have. So in that particular case, how close the objects in the cluster center could be the measure. So therefore, what we do, we'll calculate. There are different measurements, but commonly used measurement is you can look for the sum of squared error, which means that you calculate the distance from all the points assigned to the cluster center. So the distance that you will see here is from cluster center to all the points, and then you take it as the summation, which will give you the indication. So the lower the score, then we can say it's better, which means that they are closer each other. So that's one of the measurements that actually you can use to decide the number of, k clusters. Okay, the second one that we have discussed is you don't have to really worry about the number of clusters. You can look at 4 hierarchies, which means there are 2 types of hierarchical clustering algorithm. You can start from top to bottom and bottom to top, which means that you can put everything into single cluster and then you can divide it. We call divisive. Or you can start with assigning each and every object as a cluster, and then you try to merge. We call agglomerative. And our discussion, we focus is for the basically agglomerative clustering. So the idea of agglomerative clustering is you start with each individual objects or the instances put as clusters, and then individually you are merging them, right? So how do you merge? That's where the interesting part comes in. So based on that, we will have different, types of clusters. Right. To talk about how do you merge, you can look for the distance among the clusters. For example, you can look for the smallest, distance among the cluster points. We call single linkage agglomerative clustering. Or you can look for the farthest distance. We call complete linkage. You can look for average values. We call average linkage, and so on. So there are many other clustering algorithms are there for you to look for, right? But depending on which one you get, you will get different assignments. But most of the time, if you look for balanced clustering, which means you can see through the the dendrogram, the tree-like structure that we have seen, which will show you a balanced clustering, especially with if you use complete linkage, right? So those are the things that we have discussed under the clustering algorithms. In the implementation, I'm going to focus on two types. I will also start with the scikit-learn version of implementation of k-means, as well as in the Weka as well. So since we are familiar with the both, I would like to have a small discussion of the implementation of the two. Right. There was a question on the assignment. Oh, yes, you will get it. Like once we cover up to evaluation, hopefully we can have assignment on this one, since we have almost cover this. Yes. Yeah, I will release the first assignment within this week so that you can start on working. Okay, thanks. Right. So that's about the clustering part that we have discussed. The second one we have discussed is the association learning part, which is the opposite of, we can say, the classification. Why I say the opposite of, classification, it means that you don't actually focus on one particular class attribute, right? And we look for associations. So association rule mining is again a very interesting problem. And then in this one, what you need to focus on is you start look for something called frequent items and frequent item set, which means in any data sets, we look for something called, we call frequent items, right? Items means you have an attribute value pair. Like, for example, we can say Outlook is sunny is just one item. And Outlook is sunny and temperature is high could be taken as item sets. So using item sets, then we can generate the rules. So in the theory, we look at how do you generate items and item sets. So you start looking at a data set and you can look for one item sets, and then you can look at how many times it appears in the data set. This is called support. For example, in here we say Outlook is sunny, support is 5, which means that it appears 5 times in the data set. So similarly, you can look for 2 item sets, 3 item sets, 4 item sets, and so on. So this is exhaustive if you're trying to do it in this fashion. So therefore, in algorithmically, we need to learn like how do you efficiently learn item sets. So that's also something that we have discussed. And then usually when we look for the support, you specify some minimum support value, which is to reduce number of item sets. Because this, in particularly in association rule learning, it will generate huge amount of rules, which is not very interesting. So therefore, we need to limit it. So how do you limit is you can specify a minimum support as a parameter. Right. With that said, the next thing that we have discussed is how do you calculate or how do you generate the associated rules, which means that whenever you have row set, you can actually generate, whenever you have item set, you can generate a row set. So in this particular case, we have 3 item set, and using 3 item set, we can generate 7 rules. So if you have n, generally you can generate 2 to the power n minus 1 rules. And the next point is not all the rules are very interesting. So you have to look for the accuracy of the rule. So once you have the support, then the next one is accuracy. That means, okay, so you have in any rule, you have a left-hand side and the right-hand side. You look at how many times the left-hand side it appears and how many times the right-hand side actually confirms your rule. So which is the accuracy, or you can say that it is the consistency that we will actually get, right? So the idea is the higher this accuracy of the rule, the better. So that's what the two parameters that you can use to, select the best set of rules. And the other one is actually you can fix the roles that actually you focus on. I will show you like in Weka, how do you do that? And one of the problems is you might not see this in implementation in scikit-learn, and hopefully there are other packages that you can use. Since we are familiar with the Weka, we'll show you in Weka how you direct a particular class attribute and then use that to make use of these rules for practical applications. Okay, right. And the next set, what we have discussed is how do you actually generate efficiently, which I'm not going to discuss right now. The idea is, so in this part, what we have discussed is you don't have to do is exhaustively generate the item sets and then the rule sets. The idea is you can use the frequent item sets to generate the next item set. That means you use frequent one item sets to generate the two item sets. Then you use two item sets to generate three item sets. That's the more efficient way of, generating the rules instead of just you go through the data set. Right. I think that's all what I want to remember from what we have done from last time. So let's move on the implementation details. So I hope that you will also work with me, and then just let me know if you need more information when it comes to implementation details. Right. Okay. So for that, I'm going to go through the Colab session that we have used last time. Right, okay. So in scikit-learn, you have to search for k-means. And so under k-means, you can clustering. We have k-means where we can actually use this to find the number of clusters. So this is what we are going to start first today, right? And then idea of this is we can use that to identify how many clusters we look for. So that's why I said the parameter will be the number of clusters we have. Right. So let's start looking at the implementation details. So the first of all, you can use sklearn cluster, and we'll import k-means. Right. The first of all, let me take some simple clustering toy problem that we have discussed in the class, where we have 6 points and we look for clue cluster centers. So let me define my the data set as x as np.array, and then I'll put them as a nested array with the points. So if you remember my example that we have discussed, we have 1 and 1. It will be the same, the values that I am going to use. right? So these are the points that we have used, isn't it? Maybe you can check, right? Uh, and in this one, we need to find the clusters. The idea is we will first of all decide on how many clusters we are going to use. Okay, give me a second. So we define our data set here, and then we can create the k-means clusters. I'm going to say k-means. So usually you will get automatically. So and you can say number of clusters here. I will say clusters is to 2. Okay, we discussed the idea of random state here. If you want, like you can put that on as well, so that everybody will be get the same outcome. And then dot fit x will give you the cluster centers. And then to display the cluster centers, so we can say print k-means dot clusters, which will give you, it'll run this and it'll give you the cluster centers for you. So I hope whatever we have discussed this, and whatever we did by hand as well as this will be the same. So you can actually check and see. Right. The next one is you can also, get the labels. That means for each and every the data point, we can make the assignments. So this is X, and then these are the data points that we have used. So therefore, to get that one, we can say k-means dot labels. And in this one, you will notice that the first 3 point is assigned to the cluster. The class here it says the label 0 and 1 assigned to zeros, and this will be assigned to ones. PLT. And then, of course, we can say how do you plot this one. So we'll use the simple plot command. And then I have used as X. So let me use the first column and then second column, right? And then we can define what the symbol is. I'm going to use circles for this. And maybe I can say plt.show. Right. Okay, now you can notice that this is what we have seen in our toy problem. You can see that there are two clusters visually, but in algorithmically, let's put down the cluster centers as well to give them here for the graphical representation. So let me say, I'm going to take C as our cluster centers. I'm going to say K means cluster centers. And you can notice that automatically comes the code. So I'm going to use that. Instead of circle, maybe I will use cross. Right. So if I do like this, and you can notice, let me open up this in a new window. You can see it clearly marked the cluster centers, right? So these are the two cluster centers after k-means. So let me give you the code for this one as well. See whether we can come up to this point. So in this part, what we have done so far is we put up the clusters and then we lay down the cluster centers. So let me give you another insight from the same dataset that we have used for IRIS dataset. And I know we discussed in IRIS dataset, we have 3 different clusters. And it's not just simple, we have 4 dimensions. And if you compare this, let's quickly compare this with this very similar coding we can use to get the outcome from this one, right? Yes. So let me quickly go through it one more time. In IRIS dataset, I hope you remember we have used in the classification. So where we have actually looked at, is it session? Okay, yes. In session 3, we look at here under the dataset, the load iris dataset. So I'm going to make use of same dataset where we have 150 data points and 3 the labels. So let's see, without looking at this, just take the table. So I'm going to repeat the same with the iris datasets and the k-means. And let's play around. I know like one issue or in k-means is the selecting k, right? So let's see how this will work. You can notice that it will automatically get the code here. Very interesting. Yes. Yeah, I can almost make use of the same code without changing. Yes, it's okay. Maybe I will use the tab. This is automatically generated, by the way. I don't need the target, but so I'm going to remove that for the time being. I don't need this part, but yes, we can say, okay, number of clusters we put here 3 and the cluster centers and the labels. Okay, good. Very similar coding, except that we have used iris here. And we consider only the data part and without any labels, right? Okay. And then you will notice here, okay, we'll run this. And when you run this, you will notice that it's very interesting. If you remember our the data from the previously, you will notice this will be the cluster centers. So we are looking for 3 clusters and we have 4 features. So therefore, we have 4 numbers, which indicates that it will give you the cluster center values, right? Now, if you want to visualize this, there's a bit of a problem, right? I know. So here we have just 2D plane. But let me see if you want to visualize this, maybe we can take 2 features at the time. I hope that in our previous one, we got the first one and the third one. I hope you remember that part. So let me see the visualization. So first of all, let me give you the code for you. It's just to give you the idea of the difficulty of this with the real data when you have like, large number of features. Later in the course, I will discuss, for example, we can boil down to this high dimension into 2 dimensions, like transformation, like principal component analysis, and you can do the same. But for the time being, let's stick into this. So the code will be the similar, and you will get the cluster centers, and you get the cluster assignment as well. The problem you might notice here is like, if you remember the data set, it clearly we have 150 data points and we had 50 from each, and then you can see some changes here, right? This is based on the values we have assigned, but if you rerun, you might get different outcomes. So you can notice that every time we rerun, we might get different results, and I think we have discussed this idea earlier as well, right? So hope that's okay with you, right? To show you the cluster centers, we can use the x-axis. Let me take the code from our previous one, from the session 3, which displays the one which is easier for me to use. So I'm going to go back to my session 3. And in session 3, if you remember this one, what we have done up to here, right? So we got the data set, and this was the data that we had, and we use 2 tuples. So I'm going to use the very same code. Okay, maybe I will start with this one, right? Coming back to here, so I think I have given you the clustering part, yes, and then let me put this simple visualization. So in this one, you will notice that we get the third column and the first column, which actually gives you a good, a separation between the two. So that's the reason why we have used that for this one. So if you want to mark the same, for example, we can use very same code from the previous one. Maybe we can use the same thing. You get the cluster centers, right? I will put the cluster centers, and then I'm going to select only the 2 points and see whether how Good, we will get this one. So I'm going to run this and see. Okay, so you can notice. I think, is it clear to you? We have seen it here. Maybe we will use black. Is it blue or is it K? I don't remember. Yes, it's clay, right? So okay, you can notice, it looks good, right? So let me increase the size of the marker. I will use marker size equal 12. Okay, so I think that's better. Uh, Maybe I will copy paste the code for you. I will put in the chat. Right, okay. So same thing that we have done early. I think you can notice now in k-means, it clearly separates out we have the three types of flowers. And if you remember the name, this is the setosa. And the other two were overlapping. So you can see the cluster centers looks like this. So this is clearly separated. Hopefully, if you can change it, you will notice, I hope we can run and see. We can have two clusters and the cluster points might slightly change over these two. So maybe I can just run for some time and just show you. Maybe if I put 2 here and if I run, saying that if I just look at like two clusters, you will notice it's very clearly here. The setosa will be clearly separate from the other two classes. It's a clear separation. And if I do the same here, so you can notice, right? Very clearly, right? So you can notice it's very clearly it's separated out with k-means the two cluster centers. So that means this is one cluster, this is another cluster. Right. May I know how many of you have finished up to this point so that we can move to the next part here. So in this part, we will look at how we can have hierarchical clustering. I will use the very same toy problem. Right? And in this one, we will say, we will use cluster import. Oh, it's not that I'm going to use. Okay. Maybe you can use that one, but I have not used this. So maybe I will give my code. I will use in this one scipy dot but we'll look at that one as well. I have not used that one, but I just want to show square wise distance, and we'll actually, what we are going to calculate is the distance matrix that we have discussed in the class. So I want to show you that first. So I told you in our discussion of that, we will use distance matrix to form the clusters. So the distance matrix is something that we need to calculate, and I'm going to give you the code for doing that, where you can actually distance metrics. In this one, we'll use geometrical distances, that means Euclidean distance. So here we will calculate what we call the pairwise distances. For that, I'm going to use SciPy as well as NumPy for the implementation. And then let's put our data sets. Because I think we have calculated and we have given some data. So I'm going to say my data set as data, and we have array. Maybe I can copy from our previous code. So these are the points that I'm going to use. Right. So this is our data set. And then let's calculate the pairwise distances. So for that, you don't have to type, I will give you the code. So let's print the distance matrix. So as you can see, you can look for the distances. So we have 6 data points. So you can look for distance between one data point to all the other data points. For example, if you can see from the data point number 1 to distance to data point number 2, 3, 4, and 5. So you can notice the distances here. Right. The next point is we can actually calculate the hierarchical clusters. So let me share the code with you so that now you know how to calculate the distances, and this can be used within the hierarchical cluster algorithm, and that's what we have discussed in theory. So for the implementation of cluster, I'm going to use 2 packages. One is agglomerative clustering, that's what we are going to use, as well as I'm going to draw it as a graphical representation, which we call dendrogram. So I'm going to use scipy.cluster hierarchy import linkage and dendrogram. And then we will use from sklearn cluster import agglomerative cluster. Right. So directly in this particular case, we can draw and we can see how the data point represented as a dendrogram. So let me say it's D. We use dendrogram. And we use data. And then here we have the parameter. Remember, we discussed whether you are using single linkage, complete linkage, and so on. So we will say single. And then this should give us the dendrogram like this. So you can notice and also the distances here. So you can notice that you can see it here as well. So this will merge 0 and 1 with the distance of 0. So can you notice here? It'll merge data point 0 and 1 with the distance of 0, which is evident here as well. So the distance is 1, yes, between 0 and 1. Similarly, if you look for the fourth and fifth one, here also the distance is 1, right? So 4 and 5 also will merge with distance of 1, right? And then it'll readjust, right? Remember, we discussed this idea of, you have to now merge these two clusters, and then you have to calculate the minimum distances. And from that, you are going to select, right? Out of that, you will have 0 and 1, and then it'll merge with the 2, the distance as 2. So you see it here as well. So which is what you have noticed here with the single linkage. Right. Let me share you the code with you. Few things that I want to discuss here. For example, we have used single linkage. Let me open up the outcome of this one. This is a toy problem that we have noticed. So depend on which algorithm that we have used, you will notice that it will actually merge in slightly different way. So for example, let me use the same with different values. So the possible value for this is what we discuss is only single and complete, but you can use average and odd as well. Let me use complete. So you can notice that the cluster formation. I told you like you will get some kind of balanced clusters with the complete. So this is a slightly different representation. And notice the change of distances. Similarly, let me try the other two as well. Let me put average. So look at the different formation in the data. And the last one, right? So observe the 4 different values. So replace the same, method. I put down the values. Try the method. So you can try with complete, average, and odd. try the three and observe the outcome. So when you compare the four techniques, we covered single linkage and complete linkage. And single linkage, we got the minimum distances between any 2 points. In complete linkage, we got the maximum distance between any 2 points in the different clusters. The cluster shapes, if you look at, you will get a chain like, structure in single linkage. Usually it says that it's very sensitive to, noise, right? So you can look for, you can use that for irregular shape clusters. But if you look at for compact clusters, you should go for complete. I told you it's balanced. When you want to look at, the clusters in a balanced form like this, then you can go for that. So if you want to use for in general purpose, maybe then you can look for average clustering, or we can also try for what. So both are gives you they are not very sensitive to noise if you look at both average and mode. But for example, Word, if you look at it, you can use when you have equal size clusters and the data is numeric, then you can go for those. So you can actually look for the explanation which one you are going to use, right? So different methods actually prefer for different types of problems that you can actually look for that, which one you should use for that, right? So in generally, if you have no idea about which one to use, maybe for the balanced performance, maybe you can go for average there, right? When you're not sure, so although we have not discussed in the theory, you can use the average one. So that means it will calculate the average distance between the 82 clusters. That's the one it goes to use to merge the clusters. Sorry about that. Okay, right. So that's about hierarchical clustering, right? So the next thing that I would like to discuss is you can try this the same with the iris. I'm going to pause for that. Maybe you can try it as a homework, but let me first finish association learning, and then I'll come back to this one if the time permits. Otherwise, I might not be able to cover that part, right? So, but we can discuss, the implementation again. But I think you can follow the same steps to see the similar pattern with iris as well, right? So try this, and I'll come back to that. So what I want to check for this with the what we called association learning. So what I want to do is I want to make use of um, another data set. So I'm going to actually give you some data to work with, and I'm going to use the Baker for this one. So therefore, I will give you both the data to work with you. Right. So let me switch my discussion to association learning or association rule mining. Right. Now, as I told you earlier, I'm going to actually make use of uh, data set. So I'm going to give you the code to generate the data set, and then instead of, save. So I don't know whether I have mentioned this earlier, but let me briefly elaborate. In Weka, they have used a special data format, which is called ARFF format, which uses special keywords to represent different parts in the data code. So first of all, in ARFF, it uses a keyword relation to say about the data set. I'm actually represent the weather data set that we have discussed in the class. And then the keyword attribute represent each of the attributes. So we have 5 attributes here: outlook, temperature, humidity, windy, and plane. The curly brackets indicates when you have nominal or categorical data. If you have numerical data, you can just type numeric here. But since we have categorical or nominal data, we use a curly bracket and we represent the set form. So this represents that Outlook has 3 different types of values: sunny, overcast, and rainy. So this is the attribute representation. And after data, then you list the data part of this. Right. So I will share this part with you. Right. This is the ARFF data. And then what I'm going to do is I'm going to create a file using this one. For that, I will save it as a file. And let me give you the code as well. So simply, I will create a file called weather ARFF, and then I will write down. If you go to folder now, you should observe that there's a weather ARFF file inside your the general folder. So you can see there's a local file generated with the code. Right. Now that we have the file with you, right, I'm going to load the dataset with Wake-up. Again, I will give you the code for that. I will load the dataset into using ARFF loader class. Okay, before that, I think we have to start Wake-up. So I hope you remember that we have to use a couple of ideas that we have discussed early. Let me start from the beginning. Right. Few things we need to do before this one. So I'm going to take the code with you. First of all, we need to have the Weka in here. So I will make sure that whatever the required packages are loaded and installed. So simply, I'm actually having the Java Bridge to work with Python, and then Python wrapper for Weka. So we have to set up all these 3 before we start working in Weka, which I think we have discussed earlier as well. So I think I have given up to this. So let me give you this one as well. So this is to set up the Weka in the Colab environment. And once you set it up, we can just check whether this is properly installed using Java version and Java compiler version, which again we have discussed last time. So still it is installing in my machine. Right, done. Then let me see. We have, yes, no issue, it works. So I checked the installation, so you can do the same. And once you do that, right, you can start it. Right, hopefully. Okay, so first of all, we need to load some, right, JVM, right, we have this one. Okay, so I'm actually sharing that one as well. So start JVM. Now it should work. Yes. This might be a little bit tricky. I know this has happened last time as well. Yes. And finally, you can have the data is loaded, and if it is working perfectly, it should print the data. Okay. One thing I want to highlight, although scikit-learn will give you like many classifiers, unfortunately, there's no implementation as far as I know. There's no functionality for generating association rules. But there are other Python packages. You can actually find out. There's a package called mxtend, mlextend, I would say, that will support this algorithm is called a priori, which supports a priori algorithm, which generates frequent the rules. Since I actually talk about various different algorithms together with the Weka, so I thought of sharing the Weka implementation. Right. With that said, what we are going to do is, let's see how to generate association rules. We can use, let me see. So we can use Weka association a priori, and then you can decide on different, types of, parameters to look for. So here, there are some options available that we will indicate that there are 9 rules that we are going to remain. So that information is given as the option, and then all the detailed information, which means all what you call the item set information is also that is also indicated here as an option. So let me share the code with you so that you can do with me. So now let's run the code. If you run this code, I told you this is a priori, and then it automatically selects the supports and the confidence, the 2 parameters. Remember, I discussed about the support, meaning that how many instances you have to get it selected, and the accuracy, the minimum accuracy for each of the rule. It says 90% here. And it says that it's repeated this for 17 times. And if you read and go through the result, you will notice that it will show you all the information regarding the item sets as well as the rules. So you can notice that it will give you one item sets together with the item set and with the support. So it says Outlook Sunny appeared 5 times. Humidity normal appeared 7 times. Sorry. And so on. Similar to that, it will show you 2 item sets. Outlook Sunny and temperature hot appeared 2 times. Right? Likewise, it lists all the 2 item sets. Then 3 item set, it says there are 39 3 item sets. Outlook Sunny, temperature hot and humidity high is 2 times. And then it will show you there are 4 item sets, 6. And then Outlook Sunny, temperature, humidity high and play is no appeared 2 times. And there are no 5 item sets, that's why it's not appeared. And it shows you the best rules found. Right? So in that particular case, what it shows you is all the associated rules. And you can notice that you have a left-hand side and right-hand side. It says that if the Outlook is overcast, then place yes. So there are 4 instances with Outlook is overcast. All the 4 instances place yes. I hope you remember this pattern we have observed in the beginning as well, right? So similar to that one, let's look at the different one. If the Outlook is sunny and play is no, there are 3 instances. Out of that, it will predict the humidity is high for 3 times, which is very interesting rule. So to understand the practical implementation of this, you should use this for a data set like supermarket data set to see how people purchase items, and then you can actually recommend items based on what they purchase, right? So that you can actually fix the class, right? Yeah, and then you can look for the confidence level. So you can see the minimum confidence we set for 0.9. So almost every has confidence of what, right? Which means 100% accurate based on the data. Right, okay. I can give you like data set like supermarket data set so that actually you can actually see very interesting problems. Okay, so which code I missed to share? Right. Yes. Did I miss something to share with you? Which one I missed? So I think I shared this part. Yes, that's I shared with you. Did I share this one, loader dataset? Yes, that is also I have shared with you. Import one loader, that is also shared with you. Java version, that is shared with you. And then installation version shared with you. Yes. This one also shared with you. Okay. And then ARFF. Amrit, if you miss particular one, if you let me know, I will copy paste again. Right. One thing you can try it out is the supermarket dataset. If you install Weka, this is available, but since you don't have, maybe I will share something that is very interesting. Instead of weather dataset, from this point onwards, you can try, okay, where we have, okay, instead of this, you can actually use, maybe I will share with you. So I'm going to share you another data set, which is very interesting, which I used to use in Weka, but I think I can share with you right now so that you can try. Um, and maybe I can show you the usage of this one. Now, I told you like this is very interesting when it comes to transaction data sets. Transaction means with, in a supermarket environment when people purchase items together. This will be very, very interesting, right? So I'm going to share with you a supermarket ARFF, which is very interesting. What you can do is you can simply upload here. So I'm going to upload it here. So maybe I can reduce the size. So here I have the weather data set. So first of all, download the supermarket ARFF file that I have shared with you, right? And then what you need to do is you can upload. I think I have given you uploading code as well, but simply if you can drag and drop here, we'll upload the data set, right? Only problem here is every time when you run the code, you have to upload it because it's temporary. Whatever we store here will be temporary, right? Now you can notice that I have a supermarket ARFF. So I will repeat the same instead of this. Okay, I just want to check whether the supermarket, whether I have some class. So maybe I don't have. So I'm going to just go to coding. I'm going to go down. So I will remove the last two parts and then I will here put supermarket. So hopefully this will be okay. Supermarket. Let me see whether it's working. Yes, it's working fine. So now that I have changed the data to supermarket, you can open the file and see what is inside the supermarket. It's basically indicate what people purchase together in each and every iteration. So now I'm going to use the same code. Let me use a code. And then I'll put some more files here. Maybe I will say 20 so that I will get the first 20 rules. Right, now I have changed that value. So let me run this. So this might take some time because it's a comparatively huge data set. As I told you, you can open it in a text file and see what is inside. So you can see it takes some time to evaluate. And this will take more time when you have large data sets. Right. I think I got the answer. See whether I can share with you. Right. Let me give you the code for you as well. So this is how to load the dataset. The similar code we have used earlier. Right. And then association rules. So let me elaborate what we have got here. So here you can open the dataset and to see this is huge, you can notice, because that's one of the problems that we have discussed when it comes to association roles compared to classification roles, because it can give you any combination. So you can notice that how large it is, right? So I'm going very up. Sorry, I missed it again. I will automatically go up, right? The point that I want to make it here is to just to show you like how complex this could be for the larger data set. This is also, although I said larger, I think we have about like 4,000 records, if I remember correctly. We can have a look. Right. So you can notice here, you can press Control Home to get onto the top in case if you run into the same problem as mine. So you can notice here, the minimum support, it has automatically chosen as 463 instances. That means to be selected, you need to have at least 463 instances. Minimum confidence metric is 0.9, that is 90%, right? So size of the set of large items, it says 52 one item sets. You can notice the department one is the largest one. Baby needs is the second one with about 600 plus. So you can notice how large it is. But when it comes to two item sets, there are 634 two item sets, right? Again, I think we don't have to go into details. But when we go down, so it lists out the number of item sets first. So let me go down. I will type Control N so that I will go down in this list so that I will have the rules. Okay, this is the interesting part, only just the rules. So the best rule finds, you can notice here, maybe I will go through the first view just to indicate like how it look like in a supermarket environment. So you can notice here if the customers purchase biscuits, frozen foods, party snack foods, fruits, vegetables, then you can notice that they will purchase bread and cake, right? So this combination you can notice is 510 records, whereas 478 records, you will notice that they have purchased bread and cake, which is confidence is about like 94%, which is something very interesting. So that means when you want to recommend products for your customers, and then you can look what they have purchased. So this is the left-hand side. And then you can recommend the right-hand one. So if your customers are purchasing this one, then you recommend this one. This is the recommended systems that you notice. Like, for example, in YouTube, when you visit the YouTube, you will notice that whenever you watch the video, next time they will match similar videos, which is based on the same ideas and principles, where they will have reports of what other people watching in the YouTube, and then they can match. If they have watched something, and then they can obviously see, with similar interest, similar videos, you can actually recommend what you should be watching, for example. So same goes here as well. So that's what you notice here. So another thing is you can actually make the right hand side fixed. So that means you can decide what needs to be recommended, and then based on that you can actually look for your left hand side. That is also possible here, so that you can actually recommend the product for your customers. So I hope that this is useful for you to play around with this one and to get an understanding how useful association rule mining is, right? Any questions on this one? Okay. Dylan asked like finding best rule. Does the model consider only the confidence level or based on all parameters? Okay, it's like this. Now, to control what or how many rules that you are going to get, you have to control two parameters. The two parameters are the support and the confidence. Support means I told you like how many times this will be supported by the records in the dataset, right? I told you the minimum support. Confidence is how accurate those rules generated from this process. That means we have a left-hand side and a right-hand side. That means how accurate given the left-hand side where you will see the right-hand side. That is the confidence. So those are the two measurements that I have to use. Now here in the parameter, what I said, I need 20 rules, right? In the parameters, what I said was I need 20 rules, right? If you remember, let me show you. In my code, what I put is the parameters here is how many rules I want to keep, like here, the number, right? But of course, you can say the support and the confidence, then it automatically gives you the number of rules, right? So it goes like, actual, the two parameters are the support and the confidence, right? Those are the two parameters normally we will say to control the number of rules generated from this algorithm, a priori algorithm. Dylan, I hope I gave you an answer. Maybe you can search for more information on this one. So you have to actually optimize both support and the confidence. And the two parameters, the two main parameters of the a priori algorithm, right? Particularly in theory, you will notice a priori algorithm is support and the confidence. So those are the two parameters which controls the whole rule generation, process. And thanks for asking that question. Okay, anything else that you would like to discuss? Right, few things to note then.